Okay, loading. Then I will share my screen just now so we can start. Oh, but are you guys still able to hear me?
Yes, ma'am.
Right. Let me share my screen and do let me know as soon as you guys are able to see so we can start. Are you guys able to see?
Yes, ma'am.
Okay. Can't find a pen, guys. So okay. Everybody's able to see. Grace, Busisi, where are you guys able to see Langeli here? Are we all
Yes, ma'am.
good? Cool. Thank you, Busi and Grace. Okay. We're gonna continue with this expressions, and the first one that we are having here, it's 108 x cubed y plus 75 xy plus 35 x to the power of 4y minus 18, right? They say how many terms are there in the expression above? How many terms do we have here?
Four.
Oh, four. Everybody says four.
Yes, ma'am.
It's one, two, three, and four. Perfect. Absolutely perfect, right? So we have four terms in that given thingy. So terms ne are usually separated by plus, minus, multiplied by, and also divide by, right? So, guys, let me try to do this. Yeah, that's good. They say how many terms? We said it's four, so I'm just gonna write four over here. And yes, and then they say what is the coefficient of x? What is the coefficient of x?
Ma'am,
Sorry,
ma'am, it's 75.
75. Let's see what's in here. Um, Langeli here, what do you say? What is the coefficient of x?
5.
What? 5.
Yes.
Did you see the expression? Okay. Let's see. Grace,
Yes, ma'am.
what is the coefficient of x?
75.
75. Okay, that's the three of you guys. Okay, let me bring back the screen. I just wanted to check how many which guys.
Ma'am,
Hmm?
I cannot see your screen, ma'am.
You cannot.
Now I can, ma'am.
Can. Okay, that's good. Okay, button. Okay. So guys, are you all able to see?
Yes, ma'am.
Okay. So the coefficient of x is going to be coming from here because this is where we have x. But it's not just x. Do you see that there's y as well? Do you see that? Do you guys see that?
Yes, ma'am, we can see.
Yes. So for them to get 75xy, they probably multiplied 75 with x and y. Now, which can be what? Which can be 75 y multiplied by x. Okay, it will still give them the same thing. So that means if we take it like the 75y multiplied by x, it will give them 75xy or 75yx is the same thing. So it doesn't matter which one is written first, okay? As long as everything is there, it's the same thing, okay? So now this is our answer over here. Our coefficient of x is going to be 75y, not just 75. So it's going to be 75y. Okay, so basically, when they're asking you about the coefficient, they just want to know what is it that's with the x, right? What is with the x? What is next to the x, or whatever that term that they want you to give it to them. They simply just ask you uh what is it that we're going to multiply with x to give us that very same thing? So you should also take it like that, okay? So if you multiply 75y with x, you'll get 75yx or 75xy. Does it make sense?
Yes, ma'am.
Everybody happy?
Yes, ma'am.
Okay. I'm not sure what's happening here. Thing is, I can't even go back. Okay. Yeah. Okay. Um. Okay. Hi, Bo. Oh no. Guys, I don't know what's this. Eh? Oh, guys, have you ever seen something like this? I'm trying to use the eraser, but it's not working. Guys, are you still there?
Yes,
Yes,
ma'am, we're
ma'am.
still here.
Okay, let me just try to work the whole thing. Let's see. Okay. Um. Yeah. 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 Oh, guys. Um. Or could it be my phone? Okay, guys, I'm gonna bring back my screen now. I'm not sure what was happening with the screen. Okay. Guys, are you able to hear me?
Yes, ma'am.
Okay, I managed to fix it. Let's see what happens now. I guess able to see.
Yes, ma'am.
So it's 75 y. Now, do you guys understand or did you get why I'm saying the coefficient of x is 75y?
Yes, ma'am.
So basically, when they say what is the coefficient of x, they want to know when you take the x away, what are you going to be left with from that term, the whole term. So basically, you're just gonna look at where there's x. So here is x, okay. Over here we have x. So when we take the x away, what do we have? What we end up having when we take this x away, we end up having 75y. Basically, that's it. All right, great. Did you get that? And Langeli here.
Yes, ma'am.
Okay, now they're asking what is the degree of the expression in X. Let's see. I haven't seen Langelisha answering. Is he still in here? Yes, he is. Langelisha,
Ma'am, I don't know what a degree is, ma'am. A degree of X is, ma'am.
okay, we'll come up to you. Let's check Grace.
Ma'am, I think it's 3 and 4.
Mm-hmm. And then let's see. Busi,
Ma'am, I also think it's 4, ma'am.
you also think it's four. And
Yes, ma'am.
why do you guys think it's four?
Because, ma'am, it's the highest exponent.
Perfect. You just answered us. So I show speed, no, not I show speed, but Langelise, when they say or they talk about the degree is the highest exponent of four. It's the highest power of four. Sorry, highest power of x, which is going to be four. So it's going to be fourth degree of four, just four, right? They just want to know what is the highest um thingy, highest exponent or highest power of x, which is in this case is going to be four. So it's fourth degree. Does it make sense?
Yes, ma'am, it makes sense.
Perfect. And what's going to be the highest, or what is going to be the degree of expression in y?
Ma'am, 4.
Y? Y?
Oh, why?
Y? For y is going to be 1, right? Because the highest power is 1, right? Are we happy?
Yes, ma'am.
Okay. Let's see. Let's see. Let's go to the next question. 6.2, they say given the expression negative a plus open bracket 2b minus 2a close bracket to the power of 3, you're given that expression, right? And then they say determine the value of the expression where a, or if a is equal to negative 1 and b is equal to positive 2. Grace, what's the first step?
Substitution.
Substitution. What are we substituting? What am I gonna have when we substitute? What should I write?
-1 plus bracket 2 times 2 minus 2 times 2 close bracket to the power of 3.
Do I put brackets?
Yes, ma'am.
Okay, so I'm going to have negative open bracket negative 1. Is that what you said? Is that what you meant?
Yes, ma'am. No, ma'am, I said -1 positive bracket positive.
Wait, you said negative?
-1 plus
Wait, negative. Oh no, negative. Why? Okay, negative 1. Mm-hmm. Plus.
bracket
Uh-huh.
2 2 times 2
2 times 2. Mm-hmm.
minus 2 times 2 minus 2 times -1
Mm-hmm.
bracket
Mm-hmm.
to the power of 3.
To the power of 3.
To the
Yes.
power of 3.
Mm-hmm. Bless me. Mm-hmm.
Now do I carry on?
Yes, please.
Then you're going to say a negative times a negative and a positive equals a negative. So -1
Mm-hmm.
um bracket 4 minus mm, ma'am, can I quickly calculate?
Okay. Langelite. Let me have a space for you on the side. What is it that we need to do here, Langelite?
And first you write negative bracket -1
Mm-hmm. Yes.
Ma'am, may I ask, is a -1? Mm, yes, ma'am. Next you write plus bracket 2 bracket 2 minus 2 bracket -1. Close close bracket to the power of 3.
Mm-hmm.
Ma'am, next you write +1 plus 4
Negative.
-1 plus bracket wait, not -1, +1. 4
Able.
plus 2 close bracket to the power of 3.
Mm-hmm.
Then next you write 1 plus 1 plus 64 plus 8.
1 plus 64 plus 8. Where did you get the 8? Where did you get the 64 from?
By timesing 4 by 3. By putting 4 to the power of 3, and that was my answer when I put in the calculator.
Mm-hmm.
And the final answer will be 73.
Okay, what is 6 to the power of 3?
And 6 to the power of 3 is 216.
216.
16.
And then you're saying 4 to the power of 3. How much did you get? You got 64.
Yes.
You did 2 to the power of 3, which obviously gave you 8. So you see, when you say what you need to do is to work what's in the bracket first. Remember this 3 that you're seeing here, it's not for this and this only, right? So it's not like let's say for example, let me show you example there. Let's say we had A plus B in brackets to the power of 3. This is not the same as A to the power of 3 plus B to the power of 3, okay? So this is not going to be correct, but the correct one is going to be A. It simply means that whatever that's down here has to be multiplied by itself 3 times. Remember the last time we met, I'm not sure if it was you guys. I said that the exponent, I think it's you guys. We said, is it you? Where we were explaining the reasoning behind exponent. What does exponent mean? Was it with you guys?
I can't remember, ma'am.
Can't remember what. Okay, let me ask the question now. What does exponent mean to you, Grace? What does exponent tell you, Grace?
The amount of times a number is times. Ma'am, exponent means the amount of times a number is times by itself.
Okay. Busi, Busisiwe,
Yes, ma'am.
what do you have to say?
Ma'am, please repeat the question.
What does exponent tell you, or what does exponent tell us?
Ma'am, how many times the number was multiplied by itself?
How many times a number was multiplied by itself?
Yes,
Langeli,
ma'am.
Mom, am
Langeli,
I calling me?
what?
Am I calling me?
Yes.
May you please repeat the question?
What does exponent tell you?
Tells me how many times a number is multiplied by itself.
Okay, just like everybody in here understand what does exponent mean. So basically this is what's gonna happen. So it's going to be A plus B there, close the bracket. This is the first time. And then this is the second time, A plus B, and then we close the bracket, A plus B. So you see, it's going to multiply each other 3 times. Okay, it's going to multiply each other 3 times. So you see, already you are multiplying A with A, which is going to give you A to the power of 2, sorry, A squared, A squared. And then you're going to be multiplying A and B, which will give you AB. So you see, there's no AB here, which means our answer has a better chance of not being correct, right? So now, let's do ours. Who? Langelihle, let's try and do ours, right? Let's work with what we have. We are having 4. Sorry, not K, but 4 plus 2. Now they say it must multiply itself for 3 times. So it's going to be 4 plus 2. 4 plus 2. I mean, that's if we don't want to uh, simplify it from the get-go. And then we have 4 plus 2. right? So if we have something like this, remember, if the bottommost says you must work with whatever that's in the brackets first, if you can be able to like simplify it, do that, right? Do you guys remember that bottommost is our very best friend? Perfect. So we're gonna check, can we simplify this? Can we? We can absolutely simplify it because it's just numbers. Numbers can be simplified. Okay? So now we're going to check 4 plus 2. What is it? It's 6. And then in brackets, obviously. And then 4 plus 2 is 6. 4 plus 2 is 6. So basically, we're going to multiply 6 with 6. We're going to get 36 and then multiplied by 6. So the last one would be 6 multiplied by 36. I don't know how much it's going to give you guys. How much?
216.
1.
216.
216. So what is everybody getting? Is this what all of you are getting? 216. So guys, make sure that you don't make that mistake there. But otherwise, this is how you do it. Who? Langeli said this is exactly how you do it. You're on the right path. And also you must make sure that when you are given the values, the if values, you have to make sure you put them when you substitute, you put them in brackets all the times. So every time when you're trying to check if your answer is correct, or when you're trying to substitute if they've given you the ifs value, or you got your x value or your y values, or in this case they've given us the value of a and the value of b. What we need to do now is to then substitute and check for the answer or calculate for our answer without the use of a calculator, right? So now what you're gonna do when you substitute, you make sure that when everything that's gonna be put into the main thing, main expression or main equation has to be in brackets so that you don't switch signs or you don't miss signs, right? Because signs are very much important. They can mess up your whole answer. Like in this case, you see, in this case, we forgot to put the -1 in brackets and then we carried on with the -1, which will make our answer to be incorrect, right? So you should make sure that you put everything in brackets. When you are substituting, we put it in brackets. Is that clear?
Yes, ma'am.
Is that clear to everybody? Any
Yes,
question?
ma'am.
Langelihle, any question?
No,
Raise
ma'am.
it?
No, ma'am.
No, that's good. Lucy, are you still good?
Yes, ma'am.
Okay, how are you feeling today?
I'm feeling better.
You sound much better today. That's great.
Yes, ma'am.
Okay. Let's see. We have 6.3.1, which is -3a, open bracket, a plus b, close bracket, open bracket, 2a minus b squared, close bracket. They want us to simplify this. What is the first thing that we do? What does Botma say?
Brackets.
Brackets. Very bad. Botmas. We have brackets. And what do we do with the brackets? We want to remove the brackets. How do we remove the brackets? Busi, uh, how do we remove the bracket in this case? We have 3 negative 3a open bracket a plus b close bracket open bracket 2a minus b squared close bracket. Busi, Busisi, where are you still here?
Ma'am,
Mm-hmm.
ma'am, I think we wanna start by distributing the needs of 3A.
Distributing.
Yes, ma'am.
How?
Oh, ma'am, I think we multiply the two brackets together, ma'am.
Multiply the two brackets together. I definitely can back you up on that. So this is what we're going to have when we multiply the brackets together. Let me use red for danger. Okay, we're going to multiply a with 2a. So the negative 3a will remain the same. Negative 3a. Now I'm going to open a big bracket and everything is going to be in one bracket. Okay, so it's going to be a multiplied by 2a, which is going to be how much? 2a squared. Okay. When we multiply the same base, we add the exponent. Remember, there's one. So it's going to be 2 multiplied by, and there's invisible 1 here. Okay. So it's like 1a to the power, 1a to the power of 1. Ne? That is a, right? So 1 is going to multiply with 2, and then we get this 2 over here. The invisible 1 before a, these two will multiply each other. Then we're going to get 2, and then a multiply with a to get a to the power of 2 because the 1 and the 1 are going to add each other because we said when we are multiplying the same basis, we add the exponents, right? And then we're going to have 2a to the power of 2. And then the next thing that we're going to do is to multiply this a over here by negative b squared. Positive multiplied by negative will give us a negative all the times, right? So it's going to be negative a b squared, okay? Because there's no common things here, right? The base is a in the side and then the other side is b. I mean it's a and b, yes. A and B. So we can't add the exponents because they don't have the same basis. We only add the exponents if the bases are the same. If we have A and A, we're gonna add the exponent. If we are multiplying A with A, we're going to add the exponent. If we are multiplying B and B together, we're gonna add the exponent. Or B and B, we're gonna add the exponents, right? But the moment you are adding something that's different, we just gonna multiply like the bases, not the we're just gonna multiply I mean the bases, not the exponent. Exponents are not gonna be affected because we are not multiplying the same basis. So exponents are only gonna be affected when we are multiplying the same basis. So we're gonna have minus ab to the power of 2, and then again we're going to multiply what we're going to multiply the b with what b with the 2a, right? And then we're going to have this positive, so we're going to have plus 2ab plus 2ab. Okay, and then what are we going to have? We're going to multiply b with what? B with b squared. And then sorry, it's negative b squared. What are we going to have? Grace? B multiplied by negative B squared.
Negative b to the power of 3.
Negative B to the power of 3. That's perfect. Now, let's try and look at what's inside the brackets. Do we have like terms? 2a squared minus ab squared plus 2ab minus b cubed. Do we have like terms?
Yes, ma'am.
Yes, ma'am.
Where?
Negative a b squared plus 2ab.
When we say like terms, what do we mean, Grace? What are like terms?
Ma'am, like terms are um things that are numbers slash variables that have the same that look the same.
So does AB squared look the same to 2AB? Langelihle, what are like terms in the brackets?
And I think the like terms are 2a to the power of 2 and 2ab.
2A to the power of 2. What do you understand or what do you remember by the term here like terms? What are like terms?
Ma'am,
Langelihle.
like terms. Ma'am, like terms are terms that that have a similar that look similar. And
Okay. Busi, like
Yes,
terms?
ma'am.
Yes. What are like terms?
Ma'am, like terms are terms that have, ma'am, the same exponents.
Same exponents, right? Perfect.
Yes, ma'am.
Like terms are terms that are having same exponents, right? Same basis with same exponent. The number doesn't really matter, right? But if it's just numbers only, then numbers are like terms. They can be added together. So like terms can be added together. So we are saying, or Busi is saying over here, which is correct, saying that the like terms have the same exponent. So can we try to re-look inside the brackets? Do we have terms with same exponents?
No, ma'am.
No. So guys, there is no like term or there are no like terms inside the brackets because we see the 2a like nearly said the 2a and the 2ab. See, here we have a squared, here we just have a, and then apart from that, there's another b, which makes things worse, right? And then when it comes to ab squared and 2ab, see, b has to the power of 2, and the other one has to the power of 1. So you see, the exponents are not the same. So basically, you cannot add anything inside the brackets. You can only add if and only if the exponents are the same. The exponents of the variable are the same, and the number of variables that are there are the same, and the variables that are there are the same. So if it's AB, there must be AB there as well. Not because there's B squared and then the other one has AB squared. Then you can say that they are the like terms. There must also be an A, right? They must look it's they must look number the same, but the difference must be like the number that comes before the whole variables. Does that make sense? Are we happy?
Yes, ma'am.
Okay. Now we're gonna multiply. Um. We're gonna multiply 3a. In fact, it's negative 3a with everything that's in the bracket. So we're going to start with the first one. We're going to take this multiplied by that. Sorry. We're going to take this multiplied by that. Okay, let me try to use like a different thing so you can see. So we're going to multiply this with that, which is going to give us what? Negative 6. What is 3 multiplied by 2 is negative 6. Negative 3 multiplied by 2 is negative 3 multiplied by 2 years is equal to negative 6. And then a multiplied by a is going to be a to the power of 3. A multiplied by a squared is going to be equal to a to the power of 3 because we said when we multiply in the same base, we add the exponent. Guys, I'm going to sing this song up until you get used to it. Even when you're used to it, I'm still going to continue singing it because I want you to remember this the whole of your life. And then we're going to say minus 3 multiplied minus 3a multiplied by that negative ab squared. We're going to get a positive because when multiplying a negative with a negative, we get a positive, right? So it's going to be a plus 3, and then we are multiplying a with a, right? So it's going to be a squared b squared, a squared b squared, right? A squared b squared, right? And then we're going to multiply again with the negative 3a with the positive 2ab, right? That means we're going to have what? We're going to have negative 6a to the power of 2b, right? To the power of 2b, right? And then again, we're going to multiply um, negative 3a with negative cubed, which is going to be positive. It's going to be plus 3ab cubed. 3ab cubed. 3ab cubed. Now, I'm just looking at it, guys. Do we have like terms? Grace, do you think we have like terms here? From the definition that Lucy gave us, do you think we have like terms?
Not really, ma'am.
Not really. No or yes?
No, ma'am.
No. Okay. Langeli said
No.
like terms. Thank you.
No,
Langeli,
ma'am, I don't think there are any like terms, ma'am.
you don't think there are any like terms? That's great. Um. Okay, that's cool. Uh, there are no like terms. Oh, Busi, sorry. Look at me. Like any like terms here?
Ma'am, I did say no.
Oh, okay. I didn't hear that it was you. I thought that was Grace. Okay, cool. So that means this is our final answer, the simplified answer. Let's see how many marks this carried. So it's 3 marks. See, yeah. So that means we're just gonna leave it here because there's nothing that you can really do at this except for if you want to take out a highest common factor. Let's see, do you have highest common factor? It's just a, which is not gonna make things actually it's 3a, right? So we can just say we have or negative 3a, right? Like they did here. And you say, let me just write it here. You can say negative 3a and then open bracket. We're going to have what? We're going to have 2a squared, right? 2a squared plus ab squared, ab b squared. Sorry, it's going to be minus because we have to make sure that you get a positive. It's going to be minus ab squared, and then we have plus 2a plus 2a minus what? Minus b. Yeah, minus b. Then like that. You just leave it like that. You can also leave it like this or like that. So if you've taken out the highest common factor, which is negative 3a or just 3a, this is what you're going to have in your bracket. If you want to take 3a as your common factor or highest common factor, everything in the brackets will change signs. So a negative will become positive and the positive will become negative, right? So that means if it was 3a, then in the brackets you're going to have negative 2a squared plus a ab squared minus 2a plus b, right? So that when you multiply everything inside the brackets, you get that um the thing the vice versa of the current sign that they have in the bracket. Any question, guys, so far? Are we happy? Are we happy?
Yes,
Yes,
ma'am.
ma'am.
Right.
Yes, ma'am.
Nice. Okay, let's look at this last one over here. Where they want us to also simplify. It's 2x to the power of 2. 2x to the power of 2 and then close bracket. That's all it does in brackets to the power of 3, and then plus a cube root of 27x to the power of 12 minus 1, minus 8x to the power of 4. Guys, do you remember how I said we're going to remove this? The cube root.
And may you please repeat the question?
How do you remove the cube root?
Ma'am, should I type it in my calculator? Shouldn't I type it in my calculator? Or do you want me to answer for X? Because I think for X I must still type it separately in my calculator. Or is it done another way?
Are you able to put x on your calculators?
No, ma'am, I mean the exponent's 12.
I need you to explain how do we remove the cube root.
We
Not
cube root everything.
what?
We cube root everything. Like we're gonna cube root 27 and then we're gonna cube root 12.
Wait. You're gonna cube root 27. I'm sorry.
Yes, ma'am.
Like this. Cube root 27 and then cube root what again?
12.
12.
Yeah.
Okay, Busi?
Ma'am,
Hmm?
I think we're gonna find the square root of 27, ma'am, which is 3. And then, ma'am, we're gonna divide 12 by 3.
We're gonna divide 12 by 3.
Yes, ma'am.
Why are we dividing 12 by 3?
Ma'am, I forgot the reason.
Okay, let's start with it. Let's start with this one. So this 3 is for every exponent that's inside the bracket. Remember, this 2 has what? The 2 has invisible 1 there. So this 3 is going to multiply each and every exponent inside the brackets, okay? So it's going to be 2 to the power of 1 multiplied by 3 multiplied by x to the power of 2 multiplied by 3. Are we happy with that? Any question on that?
No, ma'am.
No question. Great. And then now let's see. This is what we're gonna do, guys. This is cube root, not square root. Now, when it's 3, it's cube root. When it's 4, it's fourth root. When it's 5, it's fifth root. 6, sixth root. 100, hundredth root, and. Okay, so you call the number first, and then the root. Ne? So it's the number, then the root. So it's 3. That means it's cube root. 3 is cube, right? And then 4 is fourth, and then when it's just a square root, when there's nothing here, we just say square root, okay? Because wait, what? Yes, we say square root because there's nothing. It's the same as a number to the power of 1 over 2 ne? So when you want to get rid of the cube root or the nth root or whatever, I said, I'm not sure if it was you guys, but I said you're going to put whatever that is inside the root, and then you power it with 1 over whatever that's written here, okay? So whatever that's written here is going to play a huge role. So it's going to be um you're going to write this whole thing inside the brackets, and then after closing the bracket you're going to say to the power everything to the power of 1 over whatever that's written here. If there's nothing, we know automatically know that it's 2, right? So in this case is what we're going to do, guys. We're going to say we have 27, so it's 27x to the power of 12, and then we're going to close the bracket. Then we say 1 over 3. Then we just got rid of the cube root, okay? And then we're going to be minus 8x to the power of 4. Are you guys following?
Yes, ma'am.
Great. Any question? Are we still good?
Yes, ma'am.
Yes, ma'am.
Okay, then we're going to have what? We're going to have 2 to the power of 3, and then x to the power of uh 2 multiplied by 3, which is 6, x to the power of 6 now. But 2 to the power of 3, we know that it's 8 because it's 2 multiplied by 2 is 4, 4 multiplied by 2 is 8. So it's going to be 8x to the power of 6. Close the bracket, and then we're going to plus it. Let's see. Um, Remember I said that the square root, if there's bracket and then if there's bracket and inside the brackets there mustn't be a plus or a minus, okay? If there's no plus or minus, then you can do what Langelita did earlier on when he said 4 to the power of 2 multiplied by, I mean, plus 2 to the power of 4, right? I mean, that 4 to the power of 3. Sorry. Do you guys remember that? Langelita, do you remember this? Plus 2 to the power of 3. Do you remember that?
Yes, ma'am, I remember.
Yes, yes, yes. The only time that you can say 4 to the power of 3 plus, oh no, not plus, um, 2 to the power of 3 is if inside the brackets is 4 multiplied by 2, ne? Then you can say, okay, I can multiply this with that, then it will give you the same answer. So in this case, this is what we're gonna do because there is no plus. So you see, there's no plus in between here, so we can just say the the square root, or sorry, the exponent is going to multiply every exponent inside the bracket. So it's going to be 27. Let me zoom it in. So it's going to be 27, 1 multiplied by 1 over 3, and then x to the power of 12 multiplied by 1 over 3, like that. And then we're going to close our bracket, minus 8x to the power of 4. Okay? And then now we can just remove the brackets here because I don't think we need them anymore. So we're going to have 8x to the power of 6. And then we're going to plus it with, Busi, you said what is 23 to the power of 1 over 3? Or cube root of 27?
It's 3, ma'am.
3. 3 times 3 is 9, times 3 is 27. Yes, yes, yes. So it's 3. And then we have what? We have x. Now, what is 12 multiplied by 1 over 3? It's going to be 12 divided by 3, which is 4, right? Because 3 goes into 4. 3 goes into 12 4 times. So it's going to be to the power of 4. And then we're going to close our little bracket. And then we're going to say minus 8x to the power of 4. See? So now let me try to remove the bracket. So I'm going to have 8x to the power of 6 plus 3x to the power of 4 minus 8x to the power of 4. Um, okay, this is it. Do we have like terms in that case? Guys, do we have any like terms?
Yes, ma'am.
What are those? Which are like terms here?
Ma'am, 3x to the power of 4 and 8x to the power of 4, ma'am.
8x to the power of 4, negative 8x to the power of 4, and that. Okay, so that means we're going to add those together. So we're going to have what? We're going to have 8x to the power of 6. Now, what is 3x to the power of 4 minus 8x to the power of 4?
Ma'am, negative 5x to the power of 4.
Minus 5, negative x, 5x to the power of 4. And this is going to be our final answer. Or unless if we want to take the thing, we want to take the like term, the highest common factor, sorry guys, which is x to the power of 4. And then we're going to have 8x squared. Sorry. We're going to have 8x squared minus what? Let me see. Minus 5. Yes, yes. Minus 5. So this should be our simplified, but this is also the simplified form. This is when we have taken out the highest common factor. Okay, guys, do we have any question before I end the lesson?
Oh, no, ma'am.
No question from you. That's great. Did you understand everything that we did today?
Yes, ma'am.
Okay. Um. Okay. 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 All right. Okay, guys. I'll see you guys next time. Ne? Enjoy the rest of your weekend. Bye, guys.
Bye, ma'am.
Bye, ma'am.